All right, so I've already made a video explaining every single question on the practice final. And then I thought, what else could I do to get you guys better prepared? So I decided to go through the practice final and the final itself and count up how many different types of questions there are, so you could study those types of questions. That way you'll at least get those large amount of questions correct, right? So for example, if you're really not ready for the test and you want to either study graphing exponential growth or decay functions compared to graphing parabolas, then what should you study? Graphing parabolas. Why? Because there's so many more questions on graphing parabolas. So I'm letting you know right here on this video that there's 9 questions on simplifying, 2 of which are rules of exponents. Okay, so simplifying, in my opinion, is the easiest thing in algebra. You're just adding, subtracting, and multiplying, right? So if you know how to simplify, you should get at least 9 questions right, and that's a pretty large chunk of the test, right, the final exam. So what I did was I cut out all the different questions that are related to simplifying, and I just stuck them all right here. So like we have this one up here. It says multiply and simplify. It's a binomial times a trinomial. Now that involves distributive property and combining like terms. There's this one right here, find the product. This is just distributing, right? Distributing this monomial into each and every term, and there is no more combining like terms, it's just distributing. We even have some, like this one right here, find the difference. It's a minus sign between the polynomials. So all you have to do is distribute that minus sign and then combine like terms. So, I mean, what do you guys think of this one? This one easy or hard? R plus 7 times R minus 6. Easy. All you're doing is distributing and then combining like terms. So a lot of these are the same. Like for example, this one up here, it's distributing and combining like terms, just like this one is. But up here you have a binomial times a trinomial, so there's more work, but it's all the same concept, okay? Even this one, find the product, and it has a binomial squared. You need to write it twice and distribute, then combine like terms. So out of all these, the one that's most time consuming, the most challenging one, I believe, is the binomial times that trinomial. So let's do that one at least. So I want to make some space here. I want to delete this guy because it's the same thing. That's just distributive property. If you understand this one, you'll understand how to do this one. So I'm going to delete this guy. I'm also going to delete this one. That's just distributing and combining like terms. Nice and easy. Find the product. Well, I'll keep the rest. So here we go. Let's do this most difficult one. Let's distribute negative 7k times negative 3k. That is positive 21. K times k squared is k to the third. Okay. And then negative 7k times positive 2k. That is a negative 14k squared. And then negative 7k times negative 9k. That is a positive 63k. Now we've already distributed this first part of the binomial. Now we need to distribute the second part of the binomial. So I'm going to distribute positive 4 times negative 3k squared. That'll be negative 12k squared. And I'm going to write it right below the other k squared term. That way it'll be easier to combine like terms. And then positive 4 times positive 2k, that's positive 8k. And notice that I wrote it right below the other k. And at the very end, 4 times negative 9, that is negative 36. We've already done this before. I just want to explain one more time on this one, on this video on simplifying. So when you combine the negative 14k squared and the negative 12k squared, it's like if you owe somebody $14 and you owe somebody $12, you're going to owe them 26 of those dollars, k squares. The exponent does not change when you're adding or subtracting. It's only when you're multiplying that exponents change. Let's bring down the first term, 21 k to the third. Let's bring down the next term. When I add 63 plus 8, I get 71 of those k's, and it is positive. And bring down the minus 36. And that's it. That is the hardest type of simplifying problem on the test, and there are 9 of these. Let's do a couple more. This one right here, find the product. It's ridiculously easy. Just write it twice. And then distribute. 7c times 7c is 49c squared. 7c times 9 is 63c. And then distribute 9 times 7c. That is another 63c. And then distribute 9 times 9. That is positive 81. Combine the middle terms, and you'll get 126 of those c values. Remember, exponents don't change unless you're multiplying. And right here we're combining. We're not multiplying anymore. Bring down the 49c squared. That's a positive 126c. And then the plus 81. And that's your final answer for that one. Now, a lot of them are way easier, like finding the sum. Right there, you're just adding, right? You're combining the like terms. So on this guy, whenever there's a plus, you don't have to worry about changing any signs. I mean, even if you were to distribute a plus, put a plus in front of the b, it'll say plus b. Put a plus in front of the minus 9, it'll still say negative 9. So distributing the plus doesn't change anything. That means you could erase the parentheses or ignore the parentheses and just start combining like terms. Start alphabetically, right? The a first, and start with the highest exponent term of a. So we look at the plus 13a squared, and notice that there is no other a squared values, Daniela. So we don't have to combine it with anything. That will be the first part of our answer, 13a squared. Then we go for the next highest exponent term, which is still squared, but we have b's. So we already did the a's. Let's go with the b's. We have a negative 2b right here. We could combine that, actually negative 2b squared, and we could combine that with any other b squared. You cannot combine it with this b. It has to be a b squared. So as you can see, there's no other b squareds in the whole thing. So this is the only one. You can't combine it with anything, so we're just going to bring it down. That is a negative 2b squared. So far our answer is 13a squared minus 2b squared. And then we move on to the a's, regular a's. And do we have any regular a's? Yeah, we have a regular a right here and right here. So we could combine the 7a with the minus 3a. And let me do that. Combine the 7a with the minus 3a, and we will get a positive 4a. Again, we're just combining, not multiplying, so exponents do not change. And then we go for the b values. Are there any b values? Of course there are. There's one b right here. Let's just bring it down because there's no other b to combine it with. And at the very end, we have a minus 9. That's our constant value at the very end. And this is our final answer to this simplifying problem. We really didn't do any math besides the 7a minus 3a that gave us the 4a. That was the only math we did right here. So that's like an easy problem. All you have to do is think about it piece by piece. Let's move on to a different type of simplifying problem. So there's definitely one adding, the one we just did. It had adding. Now this one is subtracting. When we had adding, if you distributed the plus sign, it didn't change anything. But when you distribute the minus sign, it really does change this positive q squared to a negative q squared. If you put the minus sign right here on this minus sign, a negative negative changes to plus positive. So that minus sign changes that to a positive 9p, changes that plus to a negative 3p squared. So we need to distribute the minus sign when we have a minus sign. So let's distribute that minus sign, and we're going to end up with a negative q squared, a plus 9p, a minus 3p squared. And the first part, you're just going to rewrite it because there is nothing to distribute out in the front. So you're just going to rewrite this. So now that we've distributed the minus sign and rewrote everything else, we could combine like terms. We're going to start with the highest exponential term and in alphabetical order. So if you have it, what's first, p or q? P, obviously. So we want the p squared values, and all I see is this single p squared value. There is no other p squared. That's a q squared. That's a q squared. So there is no other p squared value. So that's the first part of my term, negative 3p squared. I didn't combine it with anything. And then I move on to my q squared values. I have a negative 2q squared right there and a negative q squared right there. What that really means is I owe somebody 2 of these guys. I owe somebody else 1 more of those same guys. Right? So I owe $2. I owe $1. I'm going to owe $3. So minus 3, but instead of dollars, we have q squares, right? Then we move on to regular p's. As you can see, we have a 13p right here, and we have a 9p right there. They're both positive, so when you combine them, what do you get? Positive 21p. Yeah, nobody's following me. Okay. No. So right here at the very end, what do we have left? We have a q. That's all that's left. So let's bring down that minus q. And that is our final answer for that one. So, I mean, we've been doing all these simplifying problems. This one's too easy. We already know we're going to distribute combined like terms. I'm not even going to bother with it. Now, it did say on the title that there was 2 problems that dealt with rules of exponents, and these are the 2 problems right here. Okay, so we have both of those, and they're dealing with rules of exponents. So when you have a power to a power, you need to multiply the exponents. So as you can see right here, let me get this one out of the way. As you can see right here, we have something inside the parentheses. There is no addition or subtraction, and you have a power on the outside, which means that you really have a power to a power, also a power to a power, and also even right here, it's really a 4 to the power of 1, but then to the power of 3. So since there's no addition or subtraction, we're going to distribute that outside exponent to each and every exponent on the inside, and you need to multiply them. So you will get 4 to the 3rd, g to the 15th, and h to the 18th. And 4 to the 3rd, that's really 4 times 4, which is 16, times 4, which is 64, g to the 15th, h to the 18th. So that's one special type of simplifying problem because it requires your knowledge on exponents, where a power to a power, you multiply. Okay? So keep that in mind. And there's this other one dealing with just multiplication, and it does apply rule of exponents. Let's check that one out. So this one right here, there is no power on the outside of the parentheses that we need to distribute. So this is just really this times this. So you could forget about the parentheses and just start multiplying the a's with the a's. Let me rearrange it. I want to say a to the 7th times a to the 2nd, right? And then I'm also going to say b to the 7th times b to the 2nd. So of course, a to the 7th times a to the 2nd, the rule of exponents say we have to add those exponents, and we'll get a to the 9th power. And b to the 7th times b to the 2nd, that is b to the 9th power as well. So there's my answer, a to the 9th, b to the 9th. There's only 2 problems that are on the simplification that require your knowledge on exponents. The rest are just like distributive property and combining like terms. But that wraps up, like a huge part of the final, just simplifying, right? And we should all know how to simplify. I mean, if you don't know how to simplify, seriously, you should not pass Algebra 1. So everybody should get these 9 questions right on the final exam, which are obviously scattered. They're not all together. They're scattered all over the test. And there's 9 questions on simplifying. We should all at least get that right.